Okay, section 13.3, we are studying trig functions for general angles. So after this lesson, you should be able to find the values of trig functions for angles that are greater than 90 degrees or less than 0 degrees. So here's how you find trigonometric functions for general angles. If we let theta be an angle in standard position and let p of xy be a point on its terminal side, so let's draw that. So let's start with the point p of xy. Let's say this is the point p of xy. And then this would be our terminal side. So p of xy is a point on the terminal side of our angle. And then what we're going to do is we're going to drop a perpendicular from the x-axis all the way down to that point. So this would make a right angle because it's perpendicular. This would be your y value. This would be your x value. So we could use the Pythagorean relation. Notice this is a right triangle, so we could use the Pythagorean relation to find the length of the hypotenuse. Not the Pythagorean relation, the Pythagorean theorem. And that would give us a value of r. So r is the square root of x squared plus y squared. So to find the value of the 6 trigonometric functions of theta, we are going to say sine theta equals y divided by r. Notice that we're squaring x and y, so x and y will never be negative. X squared and y squared will never be negative. X and y may be negative, but when you square them, you'll get a positive number. So you will never get 0 for r. You always get some value. So we don't have to worry about any type of restriction on r there. Cosine theta is going to be then x over r. And again, we don't need to worry about r being 0. For tangent of theta, that is going to be y divided by x. And here you do need to be careful about x not equaling 0. So if x equals 0, this y divided by x is undefined. We can't have something undefined. Cosecant is r divided by y. Again, you need to be careful if r is equal to 0, if y is equal to 0, then you get something undefined. So there's no way that we would ever have both x and y equal to 0. One of them will always have some value other than 0. The secant of theta is going to be r divided by x, so just the reciprocal of cosine. So again, restriction x can't be 0. Cotangent of theta is just the reciprocal of tangent, so it's x divided by y, and the restriction is that y cannot equal 0. So let's look at an example. So it says the terminal side of theta in standard position contains the point at -3, -4. Find the exact values of the 6 trigonometric functions of theta. Include a sketch. So let's start with the sketch. So here's my coordinate axes, x, y. And our terminal side has the point -3, -4. So let's plot the point first. So -3, 1, 2, 3, and down 4. 1, 2, 3, 4. So this is the point -3, -4. And it is on the terminal side of this angle. So what we're going to do is from the point, we're going to drop a perpendicular down to the x-axis. And we're going to label this. How far left did I go on the x-axis? I went 3 units left because my x value was -3. And how far down did I go? I went -4. I went down 4. So -3 and -4. So our first step here is to find our r value. So we have the definition above, which says r equals the square root of x squared plus y squared. So all we're going to do is plug in our x and our y. And you do want to use parentheses. Always use parentheses for the placeholder. So when we're putting in -3 for x, we're going to use parentheses, -3, close parentheses, and square it. plus y squared. So again, parentheses, -4 and square it. So we're going to take the square root of that whole thing. So your radius, or sorry, your r value is a square root of 3 squared is 9, 4 squared is 16. So the square root of 9 plus 16. This is just a square root of 25, which is 5. So r equals 5. So this length is 5. So from the center, or sorry, from the origin to this point is a length of 5. So step 2, use x, y, and r to write these 6 trigonometric ratios. If a value is undefined, then you just need to say that it's undefined. So let's state what x, y, and r are. So x we know is -3. They tell us this is the point -3, -4. Y is -4, so this is the point x comma y, so this is -4. And our r, we just found that to be 5. So then, finding the 6 trig ratios for this, we're just going to use what we defined above. So sine theta, so I guess we should probably draw our angle measure in here. This is theta. And so sine of theta is going to be y divided by r. So this is going to be -4 divided by 5. Cosine of theta is going to be x divided by r. So this is y divided by r. Cosine theta is x divided by r, which is -3 divided by 5. The tangent of theta, so tan theta, is y divided by x. So this is -3 divided by -4, which is, sorry, the way around, -4 divided by -3. So this is 4/3. This is defined, so we're good. We don't have to write undefined. Then we do the reciprocal trig function. So the reciprocal of sine is cosecant. So the reciprocal of -4/5 is -5/4. The reciprocal of cosine is secant, and so that would be the reciprocal of -3/5 is -5/3. And the reciprocal of tangent is cotangent. So the reciprocal of 4/3 is 3/4. Again, no domain restrictions here. Everything is defined. So the next part is about quadrantal angles. What quadrantal angles are, so it says if the terminal side of angle theta is in standard position and it lies on the x or the y axis, the angle is called a quadrantal angle. A quadrantal angle, they show you below, so 0 degrees would be a quadrantal angle. 90 degrees would be, because it's on the positive y-axis up at the top. 180 degrees would be as well, because it's down right there on the negative x-axis. And then 270 degrees is also a quadrantal angle because it's on the negative x-axis, or sorry, negative y-axis. So it's down there at the point 0, -r. So these are the quadrantal angles. Let's look at an example using these angles. So it says the terminal side of theta is in standard position and it contains the point 0,6. Find the exact values of the 6 trigonometric functions of theta and include a sketch. So I'm at the point 0,6. So I should have, so this would be the point 0r. So my r is 6. So if we were to draw this angle, it would be this one right here, 0,6. This would be the angle of theta. So my r is 6, and all I did was used the fact that this was corresponded to the point 0 comma r. So this was the 0.06. So use x, y, and r to write the values of these 6 trigonometric ratios if the value is undefined. We have to say so. So x we know is 0, y we know is 6, and r is also 6. So sine theta, remember sine theta from the other side is y divided by r. So that is going to be 6 divided by 6, which is 1. Cosine theta is x divided by r, which is 0 divided by 6. And this is defined, 0 divided by 6. If you plug that into your calculator, you would get 0. Tangent theta is just y divided by x, which is 6 divided by 0. This you cannot do. This is undefined. So we stated that it was undefined. Then you have to do the reciprocal trig function. So we'll go cosecant theta. So the reciprocal of 6 over 6 is 6 over 6, which is still 1. The reciprocal of cosine theta is secant theta. So this would be r over x, which is 6 over 0, which that is undefined. And then the reciprocal of tangent theta is cotangent theta. So that would be the reciprocal of 6 over 0 is 0 over 6, which is 0. So that is defined. So that's how you find the values of, or the trig functions for general angles. I just want to go back up here at the top because I think I kind of skimmed through that. So when theta equals 0 degrees, you have the point 0r, or sorry, r0. So if you see a point like this, then you could just say, okay, my r value is, and whatever your x value is your r value. Similarly, and this is the one we use below, 0r, so if you're given the point 0 comma some number, then you know, oh, this is my r value. 180 and 270 work the same way, except your r values are negative. So if you have any questions about this first part of the section, please write them down so you don't forget and then bring them with you to class, and I'll be happy to answer them.